Welcome everyone to this third day of the Layer 123 World Congress, and I'm very pleased to be able to talk a little bit about the open edge and looking at it from a very holistic perspective. The provider edge, which includes telecom and cloud providers, and the user edge. So what I want to state right up front is that there are many edges and many ways of connecting the edges to centralized data centers. And we need to look at that holistic picture as we look at the open edge. And so what I wanted to kick it off with is just a little bit of thinking about what are the forces that are likely to be driving the innovation that impact the edge, all the edges, over the next 5 to 10 years. And the way we look at it is that there are really three important dominant winds, tailwinds, if you like, that are pushing things forward for us. First is how computation is being moved closer to the edge. And notice that I have a circular set of arrows here because I want to acknowledge that there's also still a non-predominant force of some workloads moving to centralized data centers. But the movement to the edge is becoming the dominant force. And what it tells us is that we should not be thinking about edge versus centralized data centers, but an entire IT ecosystem from the cloud to the edge. And many people, I think, understand that, but it's really important that we think that way as we design our computational systems going forward. The other element, or the next element that is going to, I think, really change how we look at computational or IT ecosystems is the workload diversity we're seeing. And this requirement for diversity was really kicked off by the need for parallel computation demanded by many of the routines that, for example, for AI and ML. And that requires a very different CPU architecture. And so the days when we had the idea that we could just put 100 vanilla, all the same servers in a rack, and we didn't care which server we were using, probably isn't bearing true for today. And in fact, the workloads have become diverse. And that means the CPU architectures we require are becoming diverse. And I believe we're going to see an emerging market for something I'm referring to as composable silicon. I'll come back to that in a moment, but it's a very new, for me, a new concept. And of course, we're all aware that as we move towards the edge and new CPU architectures, we have to get serious about sustainability. And it's pretty clear sustainability comes in many, many forms, and it has to be designed in from the beginning. Whether we're looking at power consumption, whether we're looking at how we cool buildings, the densities, or the footprints of what we're doing, the efficiencies. And one also very important trend is we moved at some point to a point in time where we said, we just discard things, we don't repair them. And now we need to move back to a time where we can reuse elements and establish a circular economy. So to me, and that needs to be designed in from the beginning. If I take this one level down and I say, okay, those are the dominant trends, what sets the agenda for investment? And where are there bodies of discussion that we can leverage in order to help us? And so what I see and I put forward is as we move towards the edge and rethink our IT ecosystems, it's important that we have a community-led innovation, which is happening around hyperscale discussions leading to open innovation. And it's very important to tap that. And I will show you in a little while how, in fact, many vendors and equipment providers are already tapping into this body of knowledge. And the investment agenda or areas around IT ecosystems really is going towards how do we do at scale operations? And at scale doesn't necessarily mean thousands and thousands of servers in a centralized data center. It also means how do we do at scale operations when we're computing potentially over to very wide scale geographies, needing to manage workloads that need to collaborate in a highly distributed way, and also the computational infrastructure that's required at different locations will be different, but we still need a commonality of management and underlying firmware, which can be brought by designing for modularity and bringing modularity to the table right up front. I wanted to come back to something I mentioned a little bit earlier, that is composable silicon. So when we think about composable silicon, we think about silicon die that are co-packaged on an integrated circuit. And because we have multiple silicon die co-packaged on an integrated circuit, we can optimize each die for its function. For example, an ARM core or an x86 core. We can put in a parallel coprocessor for AI and or some sort of networking element, creating a very custom computational environment. In order to do that, we need to be able to bring the dies together through common physical interfaces, common link layers, and then common protocols at a miniature level that allows us to compose silicon integrated circuits at a larger level. Then moving forward, that's the digital world. We can see at some point where there will be potentially co-packaged optical dies or components in the same integrated circuit. And potentially, if we look at some of the research from places like IBM, which are now using analog circuitry to mimic the brain patterns rather than a digital simulation of a neural network, we might have some dies on a composable circuit that are based on analog. And so these all need to come together, and we'll see an emerging economy for vendors that offer dies, silicon die for a particular function, and then other integrators bringing them all together. It's an exciting area, really just getting started, but again, meeting a very important need. Moving forward on the sustainability front, I talked about efficiency, I talked about measurement, and one of the things here that I think people should tap into is the fact that the metrics we use today for data centers like PUE measure the building, but we're also in the process of defining metrics now that can measure the IT equipment, different ways for cooling it, be it liquid, be it immersion, and other ways to design for sustainability. I mentioned earlier the circular economy, and there is a very growing economy around taking equipment that comes out of hyperscale data centers that's only been in production for maybe 1 to 2 years, still has a lot of life left, and repurposing that, certifying it for commercial stacks, and then putting it in data centers that others could use. However, to make that happen, it means that the firmware and all of these devices has to be open so that we can make the modifications to be compatible with the commercial stacks. Well, just to make sure, I want to reiterate on what I mean by edge, and I've used the term a number of times now, and I like to use the Linux definition, which they put in the public domain around the edge, looking at the user edge and the provider edge, and understanding that the edge can come in the form of points of presence for cloud providers. It could come on-prem at data centers. It could come from central offices. It can come from near cell site towers. And then, of course, we have the user device edge where we have more constraints. One thing that's really important to understand is in all the studies that I've done is that the equipment's going to be diverse and need different silicon functionality at various locations. And it's clear AI and ML is going to be prevalent at the edge. Many of the use cases that I hear about around retail, around AR, VR, around the retail experience, maybe now around the marketing, around metaverse, are going to require AI and ML capabilities close to the end users. And really it comes back to the IT ecosystems that I've been talking about for a little while, that I want to encourage everyone to think about now as ecosystem where workloads are distributed among many locations to realize an individual use case. And that all has to be happening in a very coordinated and collaborative fashion between all the software components, but also the hardware components and their firmware to ensure compatibilities. Some of the research that we commissioned is very clear that after investment in storage and servers, one of the highest investment areas is going to be edge computing, followed by risk management and AI-enabled software tools. This tells us that and confirms our thesis around the edge, and the edge being at many, many locations, and investments needed in software technologies. We already know that software containers and microservices are a very part of enabling that future, especially needing the ability to enable a developer to write once and run everywhere. But in order to make that happen, there's also an underlying compute infrastructure that needs to be open so we can ensure compatibility with firmware, wherever that happens to reside, and be compatible with management and orchestration on a very wide scale. The other element that's also very important when we think about devices is novel ways to secure the equipment, even understanding if a physical device has been moved or in transit and is not where it's supposed to be. And then also we have many, many self-contained enclosures now coming about, designed for a wall box or to be sitting on connected, linked to a cell site tower, even physically on the cell site tower, housing half a dozen servers and a network equipment, being able to support 5G applications. So what are some of the new advances that are happening with the hyperscaler discussions and the vendor ecosystem? Well, we see some of them around the data center facilities, looking at new ways to bring chillers and cool air and liquid cooling, even immersion cooling into data center facilities. We have novel ways to do power distribution. This could be within a complete rack, but it also could be within a micro data center that's, as I mentioned earlier, bolted onto the side of a cell site tower, holding 5 or 6 servers in a disaggregated 5G networking scenario. Composable silicon, we see projects today that are already working on specifications for the interconnect, the physical and link layer and protocols to connect silicon die that then get combined onto an integrated circuit and then find their way into a server or some sort of computing element. And those are very new projects that are starting to show some fruit already. The other thing we see in terms of IT infrastructure is we see many elements coming together in terms of standardization for accelerator cards, using certain power profiles that can fit into standard servers or open servers. We see high performance, new generations of servers that are designed for high performance compute, where in fact there's no motherboard, it's just a cold plate that's at the bottom, and all the modules for the server plug into the cold plate and then are interconnected using cabling. So we see some novel architectures coming down the road that are really potentially going to change things. Other innovations that we're seeing that are hyperscaler driven include atomic clock timekeeping on cards that can go inside servers to help keep a very tight timing between servers within a data center or compute elements across a wide geography. And then we see disaggregated storage, a lot of work going on there, plus also the concept of software-defined memory. Now that we have very large memory pools of different types of memory, we're starting to need to have a concept of managing that software in a very defined way. So a lot of innovation coming down the pipe and finding its way into edge use cases, even 5G networking use cases, with some of the vendors that you see here around EdgeCore and WeWin providing equipment that are bundled in now with software from various providers, and also MyTech. But that's not the entire scope of the ecosystem. what I wanted to impress upon everyone in the few minutes I have left is that there are new vendor ecosystems popping up that complement the existing vendor ecosystems. When we look at the component area, we have the traditional vendors of Intel and AMD and NVIDIA and NXP, but we also see the likes of an ARM, of an Ampere and an ARM cropping back into the data center in the computational world, continuing to get more and more important. On the IT equipment side, we have the likes of Dell and Hewlett-Packard being complemented by Eufy Space and Inspur and Mytech and WeWin, creating additional open elements to the ecosystem. As we move up the stack to the PC equipment, we see the Schneiders and Vertivs and Lagrange of the world and Eatons being complemented by newer entries like Cool IT and Liquid Stack. On the software side, I'm pretty sure everybody in the room is familiar with these players in terms of what they do. And as we continue to move up, we have new sets of system integrators that have the potential to deal with open systems and new equipment and make them easy to install for everyone. We also move up the stack and we look at things like co-location providers that now have open compute ready data centers, so that enterprises that want to do an edge computing play and want to use open hardware, but perhaps don't want to be confined to the traditional environment, can now go to a co-location provider and find a place to hold their equipment. And then, of course, we do have the other emerging ecosystem where the cloud providers and the telecom providers are now really coming together in some sort of co-opetition when it comes to edge computing. And so I think that's something I talked about at the Layer 1, 2, 3 conference several years ago, that I believe that this was going to happen, and now we're seeing it in full swing. So, and I believe that's the right step. The right kind of synergies are there between the cloud providers and the telecom providers. So in summary, I want to thank everyone for taking the time this morning to listen to this keynote. And just recall, we do have the prevailing forces that are guiding investment around movement to the edge, creating IT ecosystems, not siloed cloud or edge, around the workload diversity, going to be driving a new emerging market and economy around composable silicon to complement what we're doing around composable data centers and composable racks. And also the need for sustainability, however we achieve that. I also think that, as I said, the composable silicon market will emerge over time because of the diversity required by workloads. And in a survey that we did, which I'm showing here, we asked respondents familiar with open compute equipment, how many of them were actually doing a sustainability project and funding it, and over 70% said they were already involved heavily in sustainability projects. So I think we can conclude by saying sustainability is really moving from the discussion phase into a reality. Well, thanks again, everyone. I hope you learned something, and hope to see you next year in person at the Layer 1, 2, 3 conference. I think you can stop recording.